Hello.
Bro,
Hello, Boone. How are you?
Anthony, good.
I know David is traveling this week and next week. So he asked me to run today's call. Are you actively working on the test chip, Boone?
I don't think so for these memberships.
Okay.
I'm just
I didn't
following
think
up
so.
on
I didn't think so. But, I think right now it's primarily um, let's see. So I heard your boss's bosses got yelled at. Your CEO.
the stock price is very interesting, sir. Almost like a junk stock, sir. Any news can manipulate it.
Crazy, crazy, crazy.
Yeah. I'm sure he will he will know how to manage it. Right, sir. See I think he has a pretty good control on the board as well.
Yeah, yeah. I don't know. I hope Intel can pull it off. It'd be nice to have a fab in the US.
I think I'm not so sure, sir. Whichever that I can drive the stock up, back to 60s, will be my farm, but I will support it. That's how I perceive it.
Mhm.
Eventually, in my perspective, is that it doesn't matter Intel's apps survive or not. That's my perception. Because if you look at alternatively, right, the TSMC and Samsung's by default you can say that it's a Korean company, but the actual shareholder is dominated by the US. And likewise, same with the TSMC's. So TSMC's majority of the shareholders is still in the US, as what I know, but it's just that some of the R&Ds are tied to the local DC in Taiwan only. But
Yeah.
eventually, this is perhaps a company, and then all the machine is actually dominated by two countries. One is ASML, the other one will be the aging process and so on. Will be the Tokyo, which is also a US dominated country. So what's the difference in this aspect to me?
Yeah. Yeah.
Right.
All right. I see Sigmund has joined us. Hello, Sigmund. How are you?
Yeah, hi Tony. How are you? I'm good. How are you? Yeah.
Doing well. It's Friday, right?
Yeah.
So are you back in the US now?
Yeah, yeah. Yeah, I came to Atlanta 2 weeks ago. Yeah.
Okay. And where are you living?
Uh, I'm living in Atlanta. Yeah.
LA?
Atlanta in Georgia.
Where?
Georgia.
Oh,
I'm
Georgia.
yeah. I'm in
Oh,
Georgia
you're
Tech.
still okay. So you're in Atlanta. Okay.
Yeah. I have one news. So as you may know, I left the Dr. Lim's lab. Recently I got I'll be joining the Dr. Bakir's lab. From
Joining. I'm sorry. Who?
Dr. Bakir, Muhammad Bakir at Georgia Tech.
Is he the guy who's running the?
NAPMP.
Okay.
The
Yeah. I met
director
him.
of NAPMP.
He's
Yeah.
a good guy. Okay.
Yeah, so yeah,
So are you still available for work?
yeah, of course, yeah.
Okay, because we're getting close to signing some contracts, so I think we'd like to talk to you. If you could just send me your contact information, I'll talk to you separately.
Oh yeah, of course, yeah, yeah.
Okay.
I sent you his email address through
Yeah,
email.
yeah, yeah. Just send it by email. That's fine.
Yeah, okay.
Yeah. Okay. So David is traveling this week and next week. So I just wanted to get a quick status update on where we're at with the test chip.
Okay. Yeah, so David and I are working on demo design. So we've completed the chiplet design with commercial tools. Uh, and
So what tools did you use for what?
for chiplet design, we are using Cadence Innovus
Okay.
for PNR. And for synthesis, I've used Synopsys Design Compiler.
Mhm.
So everything regarding the chiplet uh, is done except the bump placement on the
Mhm.
chiplet.
Right.
So we are using the Davis tool. So we are planning the bump map and defining the connectivity between chiplets like CPU and HBM.
All right. I mean, would you like access to XSI?
Actually, I have an access to Siemens tool, all the Siemens tools, because I've already have signed up for the EULA for Siemens
Okay.
tools. So, yeah, yeah, yeah.
Okay.
So yeah, I think there's no issue on using the Siemens tools.
Yeah.
Yeah.
Okay, so you're doing the bump mapping because we do have a bump map flow that we have in place. So we could show you that and you could use that. Um,
Oh yeah.
it's still under development, but we could give you some
Mm.
access to that if you're interested.
Oh yeah,
And
yeah.
okay,
I'm interested in that. Yeah, yeah.
so are you still working on the bump map, adding that to the chiplets?
Yes, yes. So
Okay.
David was taking care of the HBM CPU and HBM connection. So using
Mhm.
the HBM 5 bump maps, uh, David placed the files on the side of HBM memory chiplet and CPU chiplet, and I'm
Mhm.
working on UCIe file placement uh, for CPU to CPU connection. And yeah, it's almost done. So
So are you doing like a dummy file just with the buffer or
yeah,
just the
yeah,
wire?
yeah. Using so I already placed the buffers on the chiplet. So all I have to do is just place the bumps and um, just define the connectivity between CPUs.
So this is just a regular buffer, BIDR, just a single separate input output buffer.
Yeah, it, I've connected buffers for every piece. The AIB buffer.
Okay. So is it just an inverter basically or a non-inverting double buffer?
Yeah, for now it's just the inverter.
Okay.
Yeah.
Okay. Perfect. And remind me again on the technology.
Technology. So for chiplet, we've used FreePDK 45,
Okay.
45 nanometer, and
NAND 45.
yeah,
Okay.
and maybe for interposer, we're gonna use glass interposer.
Right. You're using the Georgia Tech class interposer.
Yeah, yeah.
Okay.
So since uh I I will work under Dr. Bakir, and Dr. Bakir is the director of Packaging Research Center at Georgia Tech.
Yeah,
So,
spell his name again.
Bakir. So that
Yeah, yeah,
that
yeah,
is his last name. Yeah,
yeah. I met him. I have his card. I just
yeah,
don't remember his name.
yeah.
Okay.
Yeah, so
well,
I'm pretty
hopefully
sure.
we're
Yeah.
hopefully we're having a kickoff meeting soon. But okay.
Yeah. Hopefully, yeah. So I would say it is easy to get like technology informations of especially for glass interposer.
Mhm.
Yeah. So yeah, I think I can also provide some information for
Yeah,
ATs. Yeah.
hang on 1 second. I'm sorry, I need to pick up this
Yeah.
call. Should be
No
a minute.
worries.
Okay, so I'm gonna let you talk. Who's that? No, no.
Hi. Oh, that's our eye. So the eyes were at the other.
Okay, I'm back. Sorry about that.
No worries. Yeah.
Okay, yeah, we could talk maybe next week.
Yeah.
So anyhow, so I guess your plan was then to use XPD for the substrate, correct?
Yes.
And when do you expect to start working on that?
Maybe after uh, the bump map generation is completed, maybe uh, start. I'm planning to start it from September. Yeah, because OCP Summit is uh, on October, mid October. So yeah, we're planning to finish the substrate design by the end of September.
Okay.
Yeah.
Okay. And so the layout is done for the what do we have? Two chiplets, one for the memory and one for the CPU, right?
It's actually 8 chiplet, so 4 CPU and 4 HBM.
Right, but how many unique chiplets are there?
I mean the kind of chiplets.
Yeah.
It's just two. Yeah,
Yeah.
CPU and
So
HBM.
it's two, and you have so it's a memory and a CPU, right?
Yes.
And you have an array of 4 2x2, 2x2 CPU.
2x2 CPU and two uh, two HBMs on the left and two HBMs on the right. Yeah.
Okay.
Hmm.
Yeah, this is a really good test case. So. Okay, and then once we have that, we can start doing lots of cool stuff. So are you planning on running an SI and PI?
Yeah. After designing the substrate, yeah, I will. Yeah, I'm definitely interested in SIMPI as well.
Okay, so you're going to use
Yeah.
hyperlinks for that?
Yeah. So actually, I'm actively using hyperlinks in my research.
Yes.
Yeah, for uh, those simulations.
Great, because so for the glass interposer, are you planning on using hyperlinks to do the extractions?
Yeah. Yeah, I'm planning to use hyperlinks for as parameter extractions and um some
Signal or
yeah
integrity.
yeah.
Okay. Perfect. All right. And how about thermal?
For thermal, I think maybe David has a plan for that.
Yeah, David's tool does thermal, but
yeah, I think
we
yeah,
have
we
we have a
might use.
thermal tool also that we can share
Mm.
with. I'd like to run that in. It actually works right in XSI.
Yeah.
Okay.
Yeah, that'd be also, yeah, great. Yeah, if you can use the Siemens tools for thermal.
Yep. And the other thing is the to generate the power models. Is David generating power models for the chiplets?
Our model. Uh, yeah. Maybe yeah. David has a tool that can generate the power model. Um, uh, yeah, but I think yeah, David has some detailed plan, but
All right.
yeah,
So we can
we
work
haven't
with
talked
it.
about it yet. Yeah.
Yeah, because have you used Empower?
Emperor. No, I haven't. Yeah.
Okay, so we do have a power analysis tool that can work on the layout. We also have an RTL Pro, which can work at the RTL level.
Oh, I see. Oh,
But when David gets back, we could talk about that.
yeah.
Yeah.
That'd be very useful in like power simulations and some power integrity simulations.
Yep.
Yeah.
Yep. And the other thing is we're looking to work with and Power can also do dynamic power analysis as well.
Mm. Oh. Does it also have like airdrop simulation?
Yes. Yeah,
Oh.
it does DC and static power
Mm.
analysis. And
Oh.
it can create a CPM model, so we can use that for
Oh.
generating the models for hyperlinks,
Mm.
power integrity analysis.
Oh, I see. Yeah. Yeah. I'm very happy to learn how to use those tools. If I have a chance, because I'm mainly working on power integrity simulation in my new laboratory. So yeah,
So we'll be able to work with the NAPMP also. So
yeah.
this will be a good opportunity to start ramping up and get familiar with the tools.
Yeah, of course.
Yeah.
Yeah, Dr. Bakir is also very interested in this kind of simulations. So
Yep.
yeah, I'm pretty sure he will like it.
Yeah, I mean, I could set up a call. Well, again, let's talk offline. This is a CDX meeting.
Yeah, of course. Yeah,
Much detail.
yeah.
All right, so excellent progress. I know it's taken a while, but now that you're back, we're making really good progress. So,
That's really that.
anything else about status?
I think that's all for on my side. Yeah.
Great. All right, well, have a great weekend, and maybe we could set up a call next week. We could chat a little bit more.
Okay. Okay. Thank you. I'll talk to
All
you
right.
later. Yeah.
Thank you.
Thank you.
Bye.
Bye.
Bye.